Hey everyone, welcome. Today we are going to look into Unity extension methods, how to use them, when to use them, and why to use them. So first of all, let's look at some messy code that doesn't use any Unity extensions. This code works perfectly fine, there's no problem with it, but it doesn't use Unity extensions. So this is our class in which we have a few messy patterns that demonstrate the things we do on a daily basis or the things we usually do in Unity. So the first example is resetting a transform. Resetting a transform means we basically reset its position, velocity and scale. And in order to do that, we need to write 3 lines of code. But what if we had a single method to just say transform.reset and that would reset all of its functionality? You can say yes, we can use a static class and create that functionality. And here I have created a static class. This is reset transform. We just pass in the transform and it resets its position. This also works, but the issue with using static classes is that first of all, it has a readability issue, meaning we read from right to left and inside out. The next thing is there is no IntelliSense completion with when we say transform. The third reason is that we cannot chain operations. For instance, let's say I want to say that I want to get the position, then I only want to change the Y position, and I also want to change the X position now. I want to say that with X. But if we want to say with X, we have to write it on a separate line like this and basically repeat our code. So we cannot change the operations. We have to specify the class name, and it doesn't feel native. It feels like an external class or utility, and it has complex chaining problems, meaning it can make your code harder to read. So these are some problems with using static classes in order to write some utility functions or in order to replace extension classes. This was a very simple example of just resetting the transform. Let's say that we want to find a string by its name. Look at all this code. Why don't we have a simple method like basically string.find by name or something like that? We can write it in the utility class, but again, it will have all these issues. There are tons of other examples like finding a collider. If it's not null, if it's null, then add the collider. Check if a component exists. For instance, we just want to change the Y position of an object. We have to write all of this code. If we want to change the X position or just want to change the Z position, we have to write all of this code again. Same goes for the conversions of vector 3s to vector 2s, and you get the idea what I'm trying to say over here. And these are all the examples. You can pause the video and read them in order to understand what they are doing, but basically these are simple examples through which we see that all of these can be converted into extension methods, and basically it will save us a lot of repetitive code. So let's convert this into using extension methods and see how we can use them and how it solves all of these problems with repetitive code. So first of all, we should see that how to create an extension method. Let me comment out this whole class and let's go to Unity. And creating an extension method is really easy. Let's say that we have a script that only handles some extensions of the transform. So we can call it transform extensions. Of course, you can call it anything you want, but for the sake of this tutorial, I am calling it transform extensions. Now this class has to be static. Now you might be thinking, why not just use this static class? But again, this had all of these issues, and once I finish this class, you will get an idea why I don't use the normal static class. Okay, now that we have our static class transform extensions, we can say public static void reset. This is our extension name. Now the syntax for creating an extension method or an extension class is that the class must be static, the method should be static, the first parameter should always be this, followed by the type we are extending, and then the name of the type. This can be anything, you can call it t, transform, or whatever you want to. Then now we will start the body of our function, and this will be simply transform dot position is equal to vector 3.0, transform dot rotation is equal to vector quaternion dot identity since it's rotation, and local scale is going to be transform dot 1. So this is our extension method. Now let's go to our messy code. Here we wrote 3 lines of code that said we want to basically reset our transform. Let's look at our extension method now. We can say transform of reset, and that's it. That's all we had to do. Now let's go again to our Unity utility class. Here I want to, let me press Ctrl Z. Here I want to say that I want to reset the transform. And here is my reset transform function. Let me remove this. Let's say Unity utils dot reset transform. Look at both of them. This looks like an extension of the transform class. This looks like an external class. You have to specify everything. You have to pass in what you want to change. But over here, it's much cleaner and easier to read. So all of the problems with the static class, readability, discoverability, no chaining of operations, always need to specify the class name, doesn't feel native, and complex chaining. Because normal static class, which is Unity utils class, doesn't allow us to chain operations easily. And as our code becomes more complex, the chaining becomes basically unreadable really quickly. So let's look at another example, which was the chain of operations. So here in our extension class, we are going to add for the transform extensions a few more methods. The first one is going to be public static, and this is going to be a vector 3, and we said that with y. This is going to take in a vector 3 and our float x. So this is going to be our vector 3 v and a float y, because we said with y, meaning we only want to change the y position. Now let's create the other ones. With x, public static vector 3 with x, and this is going to just change the x position. Now with z, public static vector 3 with z. So these are the 3 other functions extensions we created. Now let's go to Unity utils class. We also have with y. Let's create with z and with x over here quickly as well. So with x, and this is going to be with z. We only want to change the x position, so we'll pass the x over here, and here we only want to change the z position, so we'll pass the z over here. Now we want to chain the methods, which were basically, let's say we want to say Unity utils dot with y, with x, we need to pass in the vector 3. So transform dot transform dot position, we need to pass it the value of y. What's the new value of y? Let's say 10. Now here I want to say with x as well. Then I can say transform dot position dot basically transform dot position, and here I will say 10 for the x. So as you can see, I got an error. Basically this doesn't allow any form of chaining. But now let's look at the extension methods. We'll basically say transform dot with x. Let's see what mistake I made. Did I make it public? Yes. I added this. Okay, transform dot position equals to transform dot position dot with x. I want to say that the x should be 5. I can say with y, the y should be 2, and I just don't want to change the z. So here you see the difference very clearly. Look at this code. This doesn't work. It will show us an error. And also, even if it did work, look at the way we wrote it. With x transform dot position 10 dot with x transform dot position 10. And look at this. Transform dot position is equal to with x with y. Obviously, this looks much cleaner, and it looks like an extension of the transform class. It looks part of the native code instead of feeling like an external utility with the Unity utils class. It's much easier. Now let's look at something that's not simple but not that much simple. Let's say that we want to destroy all children of an object or a transform. So let's create an extension for that. Public static, always include this, and here we'll say void destroy all children. This will take in the transform, and the code is going to be really simple. We will first say for I, and this is going to be a reverse for loop. So our length is going to be transform dot child count. If it's greater than 0 and I minus minus, then we'll say that if the application dot is playing, then simply object dot destroy the transform child, else if it's not playing, then destroy immediately, which is object dot destroy immediate. Destroy immediate. This is perfect for clearing basically UI lists or respawning areas. Now let's look at the Unity util example of destroy children. This is the example. How we are going to use this? Let's simply show an example to you. Let's say Unity utils. This is the normal static class destroy children. This takes in a transform, which would be this dot transform, meaning this basically means GameObject dot transform. So this is how we are going to destroy the children. And if you look at this, it immediately destroys the children. We can also add the is playing logic over here as we did over there, but still doesn't look native. It looks like an external class. But how about this one, the extension method? It would simply be, we want to destroy the children on what? This, which is this GameObject dot destroy all children. Now look at these. This looks like part of the native code. It basically looks like part of the transform class. So with extension methods, we can create lots and lots of them, and basically we can make our code cleaner and make our code shorter, and we don't have to write all of these again, and you can use this throughout your code very easily. So this was the use of extension methods and how to use them. But in some scenarios, extension methods make more sense. When, for instance, you wish Unity had a specific method for a built-in class like a reset, you find yourself writing the same code again and again and again, or you want to make your code more readable or expressive, then use utility classes. But don't get or go too crazy, because if you are adding dozens of methods to one class, then maybe you should consider using the normal utility class instead. So I hope you guys enjoyed this tutorial, and I'll see you in the next one. And these were some really simple examples of extension methods and how to use them. Till then, see you next time.